this video, I will be going over my solution to the 2024 AMC 10A problem 24. So the problem states, a bee is moving in three-dimensional space, and a fair die with faces labeled A+, A-, B+, B-, C+, and C- is rolled. Suppose the bee occupies the point A, B, C. If the die shows A+, then the bee moves to the point A + 1, B, C. If the die shows A-, the bee moves to the point A - 1, B, C, and so on. And if the bee starts at the origin, and the die is rolled 4 times, what is the probability that the bee traverses 4 distinct edges of some unit cube? Okay, so this is a very intimidating problem, but we can kind of break it down. So here I have like a kind of sketch that I did. So we can completely disregard these back cubes because it's out of the bee's range. But so let's just like take an example case, right? So let's say I choose A+. If I choose A+, then my bee is going from the origin to this point. So let's label this point A1. Okay, so now I'm at this point, and so I traversed one edge of 4 possible unit cubes, and those 4 cubes are this one, the cube I get extending out in this direction, and the other cube I get extending out this direction that's stacked on top of this one. Okay, so hopefully we can see that, but yeah, so this is one edge of those 4 cubes. Okay, and now I can move in any direction except this way and back where I came from, right? If I move this way, I'm not even in the same cube I traversed. If I move back to where I came from, I'm just covering the same edge, and I can't do that. So I can move in a total of 4 directions. So from A1, I can move in 4 directions. Let me write that. A1, I have 4 choices to choose from. Okay, so now let's say I choose, it doesn't really matter, so I can choose like, say, C+, so then I move up, right? And now I'm at this point, so let's call this point A2. Right now, I'm at A2. Now, some people might think, oh, well, now I have 3, if I go somewhere else, I'll have 3 options, right? But you have to consider casework, because if I go to this point, for example, then I have 3 ways of completing the cube, which would be here, here, or here. I can move in 3 directions. But if I move to this point here, I only have 2 ways. I can only move here or here. And same thing if I go out to this point. I also only have 2 ways again. I can either go here or I can go down, right? So we have to account for that in our probability. So if I go, let's see, what's the probability I go to this point? That's going to be 1/6, right? So the probability I go to that point is 1/6, and then after that I have 3 options. And then the probability I go to either one of these points, this one or this one out here, is going to be 2/6, and then the probability I complete those cubes is also going to be 2/6. So, okay, let's write our probability again. So let's multiply everything by 6 because we can choose from 6 options. In my example, there's a 1/6 probability that I chose the A negative. And then for my second move, I have 4 choices, so 4 over 6. And then I can multiply that by, okay, so let's see. If I move to the point here, this is the only point where I have 3 options of completing the cube. So I have a 1/6 probability of choosing that point, and then I have 3/6 probability of choosing move to complete the cube. Or I can move to either one of these points, this one or this one, where this is like an extension. So this is like C negative, moving from A2 to C negative. So I have 2/6 probability of choosing those points, and then I have another 2/6 probability of completing the cube with either 2 of those moves, right? And so this is just our answer, so we just have to evaluate this. So this is obviously just 1, so then we get 4 over 6 times, let's see, 7 over 36 is equal to 28 over 216. We can divide both the numerator and denominator by 4 to get our final answer of 7 over 54. See, and that is an option, so B is our answer.